Hello, in this video I'm going to be talking about sprites and how we can use them. So you'll see in this demo running here, although it says 20 sprites, there are actually 40 hardware sprites running here. So you can also see that I've implemented controls as well, so you can move the spaceship character around there, just to give you something more interesting to be able to do here. Of note also is this does include a font and some simple commands to print some text on screen as well. If I show you this, then you will see here, these are the tiles in the tile map for our background characters, and these are all of the graphic tiles for the sprites. Notice how they're separated here, so you have sprite memory here, and then you have the graphics for the tiles here. So I kind of wanted to show you it all running in here first, so that when I explain things it will hopefully clear some stuff up. So first off, so when you actually download this code, one thing to be aware of is, so this code project here is currently running in Linux, so I have the GPDK home variable set to this here. But if you are running this in Windows, then you will need to change it to either C drive /GBDK/ or wherever else you've actually installed GBDK. So that's all I wanted to cover on this at the start here. So now let's dive in with some information about sprites. So loads of the information that I'll be giving you here is just from this Pandocs document online, which explains loads of stuff about the sprites. Some of the info is also from the GBDK documentation itself. So first off, I'll talk about the sprites. So sprites, or objects as they are known on the Game Boy, are movable objects that can be drawn either above or below normal tiles on the tile map. Sprites can be moved with greater precision than tiles, as they are not aligned to a tile map, so they could be moved 1, 2 or more pixels at a time in any direction of your choosing. They can also have their tiles flipped horizontally or vertically, and be either 8 by 8 or 16 by 16 pixels in size. So if I bring up this example here, so this character here, if we were to create them as a sprite, then we would probably use 8 by 16 sprites as the size. So one half would be one sprite, and then another half would be another sprite. But the way that you would lay this out in tiles, if you like, is you would first draw the top left tile, then the bottom left. This is how it would need to be arranged when you copy the tile data to the tile memory as well. Is it would expect this tile first, then this one, then this one, and then this one. So you can change in one of the sprite properties, you can flip the sprite horizontally or vertically, but one thing to be aware is when you create larger sprites out of groups of sprites, if you like. So if I change the view of this a moment, then move this one up here, becomes more clear. So this would be one sprite here, and then this would be the other sprite. So if you flipped this sprite horizontally, you'd have to flip each side. But if you flipped this side horizontally, like so, then you would end up with the flipped side being on the wrong position of the sprite. So be aware, if you are going to play around with mirroring sprites horizontally or vertically, that you would need to kind of juggle around where they're laid out when you flip them around, especially if they're composed of parts. So these are all of the graphics which are in this example here. They're obviously not laid out like this in tile memory though. If I run it again, you can see that. So if we go into tile view here, and you can see that there's a top left of the fish, then the bottom left, then the top right, and then the bottom right, and then start of the next frame of the fish. But when you pass the tile that you want to display to the sprite, when it's in 8x16 mode, you only need to pass the top left tile. It will automatically map the bottom one in. So the Game Boy and the Game Boy Color is limited to 40 sprites in total, and only 10 can be shown on any horizontal line. You probably noticed from the example that when a load of sprites were on the same line, some were kind of flipping in and out and disappearing. If I run it again, you'll see as the spaceship moves up, when there's a load of them overlapping, certain sprites with a lower priority will not be drawn. So although you can have all 40 hardware sprites running, you can only have 10 of them on any horizontal line. So it just means that you kind of need to make sure that you place them in certain places in your game. So although 256 tiles are set aside for sprite graphics, the upper 128 of them are actually shared with the background. So that's something to be aware of as well. To create bigger images on screen, we must align sprites into a table like a layout. So you can see in this example here, we've got one sprite on the left here, and then another sprite on the right here. In the SpriteManger code that I've got here, so this is a SpriteManger code for creating all the sprites. Although this says sprite max is 32, bear in mind that this is just the array limit of this. When you're actually creating sprite groups, then that will obviously the sprite group number is literally just corresponding to your array of sprites. In this code here, I'm only interested in the array number of the sprite. but I do also have to record the hardware identification number of the sprite as well. So this manager code here allows you to create either single sprites or double sprites. It would kind of change on a game by game basis really, depending on how big your characters are going to be in your game. So I've kind of used as minimal code as I can to sort of create this here. So when you create a new sprite, you pass in what type you want it to be, either a single or as a group, and then it will either allocate one hardware sprite to it, or it will allocate a second to it as well. So this variable here keeps a hold of the actual hardware identification of the sprite, so you need to call sprite init first, and then in sprite, the sprite initialization function, it then sets the ID to 0 at the start, which is the first sprite identification number. Then whenever you call the new sprite function, it will then update the ID number either by 1 if it's just a single sprite, or 2 if it's a sprite group. But what it automatically does is, if it's a group, then it will just create another hardware sprite to the right of the first sprite by 8 pixels. Hopefully that kind of makes some sense. It probably will when you play around with it more. Right, so I was saying about to make larger sprites you have to arrange them into groups, but you always need to make note of the ID number of the sprite that you're using. So some things that sprites have, so they have a vertical position, horizontal position, a tile identification number between 0 and 255, and then they also have some flags which are just extra sort of things that the sprite can actually have. So normally the sprite's horizontal and vertical position are offset by -8 and -16, so if you set a sprite to 0, 0, it would actually be as if it was off the screen, so you wouldn't actually see it. So you can actually hide a sprite by putting it at position 0, 0. So to display the sprite in the top left hand corner of the screen, you would put it at 8 by 16, and then likewise it would have to be past 160 and 144 to actually be off the screen on the right hand side. But by having it have the -8 and -16 here, it allows the sprite to move off of the borders all around the screen seamlessly, whereas on other consoles which have only a byte represent the horizontal and vertical position of a sprite, when the screen is 256 pixels wide and you're only given the sprite X coordinate the same factor, it means it would always be on the screen. So I'll talk about some of the sprite properties. or rather the flags. So as I said before, one flag is the flip horizontal flag, another flag is the flip vertical flag. There's also a palette flag. So sprites can have one of two palettes on the normal Game Boy. So you might decide that you wanted the background colour to actually be something different, and then change where all of these colours are in the palette. There's also a priority flag as well, which can be either on or off. And if that is set to on, then sprites are drawn under the background. If it's clear, then sprites are drawn over the background, which could be useful if you wanted to move a sprite over a background and say have like a tree be in front of the sprite. When it reached the tree, it would then set the priority flag to on and would then be underneath it. So the priority flags are literally just bit flags. So for example, bit 7 is the priority flag, which is 128. And then the flip X is the flip X is bit 5, and bit 6 is flip Y. All these flags are listed in the GBDK documentation for how to use them. I don't think I've actually bothered coding any of them in this example here because the sprites are 16 by 16 pixels and they use 2 tiles. As I showed in the example here, it's a pain having to try and mirror these sprites when there's two sort of groups of them. It's easier just to change the actual tile data. So let's see, what else have I not covered here? Oh yeah, one thing to be aware is when two sprites overlap each other, for example, if this one was to move this way, then on the Game Boy there is like you'd have like which sprite gets the priority to be drawn over the top of the other one. So on the standard Game Boy it comes down to which has the lower horizontal position is the one that's drawn on top of the other, which is kind of a weird way to do it. Every other console, the way that they do it is when you create a sprite, you obviously have to pass in the ID number of the sprite that you want to create, and usually the lower the ID number, the higher the priority of that sprite actually is. So the one with the lowest number would be drawn over the top of all the others on most other consoles. On the Game Boy Color that is also the case as well, but on the standard Game Boy it behaves differently. So I will now get back to the code to show some of the more interesting things. So as I was saying, what this manager code can do is it can handle moving all of the sprites for you. So at the start of the code here, so this is just an array to create a group of actors, if you like. So as it says here, we use all 40 sprites in this example here. So just like you would set the normal tile data, you also need to set sprite tile data as well. So there's a separate command for that. Which is this one here on the Game Boy. So the GBDK handles sending all the data to the actual machine itself. And then one thing to note as well in the sprite initialization code is GBDK has 2 flags which dictate what mode the sprites are in. So you can either have the 8x8 mode or the 8x16 mode. And then you also need to call the show sprites command afterwards to actually display them on screen. But there is also hide sprites as well, which would probably be useful in other scenarios, like maybe a title screen or something where you want to turn off all of the sprites. So the main functions here and their uses, so clear all kind of does the same as the hide sprites thing really. I don't really use the hide sprites. And then the set tile data here, this just creates a sprite which you need to call first off, and then it returns the starting ID of that sprite, which you can use, well, you will need to use to update its details here. So once you've created it, you can then use this command here to change its position on the screen, and also the starting tile that it will use for its graphics as well. And I've also added in this command here to hide the sprite. All it does is just positions the sprite off screen. So one thing to be aware of as well is to hide the sprites. The easiest way is just to move them off screen, but what you don't want to do is have them in an area of the screen where they could count as one of the 10 on a horizontal line. So you wouldn't want this to be between 16 and 144, which would put it on the screen. You want it to be off the screen, otherwise it could cause some of your other sprites which are visible to glitch if it was at 0 horizontally and then between 0 and 144 on the physical sort of screen. So this just moves around a group of sprites here. This command here is used to generate random numbers at the start for the sprites. So we've got random speeds, and then some of the other newer commands here. So these are some text commands. So the fonts themselves are actually in with the normal sort of background tiles. So if we have a look at some of the text printing commands here, all we're looking for here is if the tile number is greater than 0, then we'll print it on the screen. If a tile number equals 0, which is the null terminating character on a normal string, then it will break out of the print command. One thing to note is that I've not put in any constraint checks here. So if you print a string which is longer than 20 bytes in length, then it won't automatically clip that on the screen. So although that string can't be displayed on the Game Boy because the screen is only 20 tiles across, the letters would actually go outside of the screen. There's no sort of stopping that. I'll leave that to you to kind of implement if you want. Just be careful how long a string you actually pass. So print center here, how this kind of works is it first sees how long your string is. This one does check the length, and it will actually restrict the length to 20 if it goes over that. And then what it does is it then divides the length by 2. Because the Game Boy screen is 20 tiles across, it will then subtract the length from 10 and then draw the string there. Print number is a bit more complicated. So what it will do is you can pass it an unsigned value only, and then it will record, it will split that value then into hundreds, tens and units. And then it checks how many times 100 goes into the value to give you your hundreds. Meanwhile, it's constantly subtracting the values from the value you pass in as well. So it then, depending on if there is a number in the hundreds part, it sets a flag here to make sure that you draw the other 2 bytes that represent the number as well. And this bit here is the last unit flag here. So if there is a value in the hundreds, then it will force the other numbers to be drawn here. It is quite a useful function, that, so you could use it for like the score or something, as long as it was less than 256. And then the other useful functions in here as well is the reading of the joypad. So there are some different ways to do that on the Game Boy, but the method I usually use is I set aside 2 variables to hold the joypad details. One is the current value and one is the last value. And then every time in the main sort of loop of the program, call input update function, it then swaps the old value by taking the new value in its place. The new value then calls this gbdk function here, joypad update, rather joypad, that then returns what keys are currently pressed as a bit flag value. So what you have is a number of bit flags on gbdk which all combine into just 1 byte. So as you can see here, by checking against each of these bit flags, you can see whether any of the individual buttons were pressed or if a load of them are all pressed at the same time. So this function here is the key down. It just uses this command here, is bit set, to check whether the variable you pass in has the bit flag or flags set, and then returns true or false. So if our current key is pressed that we want to check for, it will return true if it is or false if it's not. And then we can use this next command to see whether the previous key pressed is the one we want. So you could kind of use this for when you release something, or if something was pressed, which is pretty useful for if you were kind of like typing something in. If you hold down the key, then it won't have any effect. It will always be false. Only when you release the key will it come true. And then it also clears the current value of old joy as well, so that you don't get a false positive the next time you read it. So hopefully this code will be of some use to you. Right, that's it for this video. I'll leave links to this code in the description, and also some links to the Pandocs articles where the information for this video came from. Right, thanks for watching, and I'll see you next time.